Another solution method for quadratic equations is the method of completing the square, which is going to introduce today, or in this video rather. Now, as you saw in the previous video, quadratic equations are equations of this form, obviously where a is not 0. But for the method of completing the square, the equation has to be of the form where a is actually 1. It has to be of the form x squared plus bx plus c. Now, if you're given an equation in the form ax squared plus bx plus c equals 0, in order to apply the method of completing the square, you need to rewrite this equation so that the coefficient of x squared will be 1. So if you're given an equation of this form, for instance, the way to achieve this desired form is by dividing this equation through by a, the coefficient of x squared. So doing so here gives ax squared over a plus bx over a plus c over a equals 0 over a here 1, and so you're left with an equation in the form x squared plus b over a x plus c over a equals 0. And this equation is essentially of the form x squared plus, let's do it this way, bx plus c equals 0. So that means I've replaced this b over a term with capital B and this c over a term with capital C. Now, for example, the equation 2x squared plus 3x plus 4 equals 0 can be solved by using the quadratic formula, because it's of the form ax squared plus bx plus c equals 0, where a isn't 0. However, if you wanted to solve this equation using the method of completing the square, you can't, because the coefficient of x squared needs to be 1. Currently, the coefficient of x squared is 2. In order to make the coefficient of x squared 1, divide through by the current coefficient of x squared. Divide through by 2. Because if you divide through by 2, you get rid of the 2 here, and you get 1, and the other terms change. So dividing through by 2, and this equation gives 2x squared divided by 2 plus 3x divided by 2 plus 4 divided by 2 equals 0. And this gives 2 here, 1. This gives x squared plus 3 over 2x plus 2 equals, okay, I should have divided this by 2. 0 over 2 gives 0. As you can see, we now have an equation in the form x squared plus bx plus c equals 0. The coefficient of x squared is 1. Now the method of completing the square can be applied to this equation, not the original form, but this form. I know the method of completing the square hasn't been explained yet, but these are the foundational concepts you need to grasp to ensure that you can answer any question requiring the method of completing the square. There's one more concept. So now you understand that in order to use the method of completing the square, the quadratic equation has to be of this form, a form where the coefficient of the x squared term is 1. And the underlying idea behind the method of completing the square is to reduce an equation of this general form to an equation of the form x plus d squared equals e. Now this may all look very complicated, but it simplifies the generation of a solution. I mean, an equation like this, in order to determine x, because x is unknown, so here d and e are just any constants. They could be any real number. The next step, if you wanted to make x a subject of a formula in this case, all you have to do is take the square root of both sides, and that gives the square root of x plus d squared equals the square root of e. And just before I proceed further, I need you to realize that the square root of a number is actually the same thing as plus or minus the square root, but the plus or minus isn't usually shown. And another thing to note is that the square root of a term squared is equal to the term. The square root of 4 squared is equal to 4. The square root of 9 squared is equal to 9. And with regards to this plus or minus thing, the square root of 2 is actually plus or minus the square root of 2. So you're saying And then let's try another example. The square root of 4 is actually plus or minus the square root of 4, which is plus or minus 2. So the square root of 4 is 2 and is also minus 2. And if you think about it, when you square 2, 2 squared is 4, minus 2 squared is also 4. So the square root of 4 is actually 2 and minus 2. So the square root of 4 is actually plus or minus square root of 4. So you need to note these two things. That the square root of a term is equal to plus or minus the square root of the term. And the square root of a term squared is equal to the term. These are the two things you need to note. So applying that here means that this is actually plus or minus. And this is actually a plus or minus here. Now, the square root of a term, x plus d in this case, squared, is the term. So we have x plus d. So x plus d is acting like how a is acting here, because it's x plus d all squared. And we have the plus or minus square root of e. Now in a case like this, when you have a plus or minus on both sides, you only consider one plus or minus. So you basically ignore one. And the convention when using the method of completing the square is to ignore the one just before the term involving the variable x, or the variable whose values you're searching for. So we just ignore this plus or minus, and we proceed and write x plus d equals plus or minus the square root of e. Now, subtracting or even just dropping the brackets, we get x plus d equals plus or minus the square root of e. Making x a subject of the formula by subtracting d from both sides. So subtracting, I'll just write sub d from both sides gives x plus d minus d equals plus or minus square root of e minus d, which is x, because d minus d is 0, equals plus or minus square root of e minus d. The right hand side, this term can be rearranged to as minus d plus or minus the square root of e. So your values of x, your solutions to the original quadratic equation, will be x equals minus d plus the square root of e, or x equals minus d minus the square root of e. Because of the plus or minus, you take the plus case separately from the minus case. Now, all this video is trying to do is show you the fundamental idea behind the method of completing the square. It's telling you that you start with an equation of this form where the coefficient of x squared is 1, and using the method of completing the square, you get that equation to be of this form where x is the variable whose values you're searching for, and d and e are just constants representing numbers like 1, 2, 3, 4, you know. And from this stage, you can easily determine x, because you just take the square root of both sides and you simplify, and you get to the point where you can say that x is equal to something plus the square root of something, and x equal to minus something minus the square root of something. So in general terms, I just want you to understand the idea that's being presented. Now in the next video, the actual method of completing the square will be introduced. The method of completing the square simply involves converting an equation in this form to an equation in this form. All that's being done is this term b and c are being placed in certain positions. So we have x, the same x variable, plus b divided by 2 all squared equals b divided by 2 all squared minus c. And you also have to memorize this. Let's try an example. So if you have the equation x squared plus 4x plus 4 equals 0, how do we convert it to this form? Well, we simply note that b, for this equation, b is 4 and c is also 4 by comparing, and you just write x plus b over 2, in our case b is 4 divided by 2, everything squared equals 4 over 2, everything squared minus our c, which is 4. And I mean, that's the basic idea. From here, you just simplify and you get the solution value. So this method of completing the square is actually much faster than the quadratic formula at giving solutions to quadratic equations. So let's try another example. If you're given the equation x squared plus 3x minus 2, which equals 0, which can be rewritten as x squared plus 3x plus minus 2, because plus minus 2 is the same thing as minus 2, and this enables us to quickly determine that b is 3. So comparing this equation with the general form, b is 3 and c is minus 2. The method of completing square simply involves going from this state to this state, and we just write x plus Replacing b with 3, 3 over 2 all squared equals, instead of b, 3 over 2 all squared minus our c. Our c this time is minus 2, so minus 2. And that is essentially the first step in applying the method of computing the square. Everything else is easy. The most difficult part is in remembering this formula, and from there it's just a case of identifying what the b and c terms are, what b and c are in the given equation, and just simply replacing b and c with this value. All you do after is just simplify this expression and you get the required values of x. So let's consider an example question. This question says, solve the equation 2x squared plus 10x plus 12 equals 0. Now, this equation can be solved using the quadratic formula, but we're concerned with using the method of computing the square, which in fact is an easier method. So the first thing we have to ask ourselves is the given equation of this form, of the form where the coefficient of the x squared term is 1? The answer is no, because the coefficient of x squared here is 2. But if we divide this equation through by 2, so dividing it through by the coefficient of x squared, we get an equation in the desired form, because now we have x squared, because 1 times x squared is x squared, plus 5x plus 6 equals 0 over 2 is 0. 0 divided by any number, excluding 0, is 0. So 0 divided by 1 is 0, 0 by 2 is 0, 0 divided by 3 is 0, and so on. So now that we have an equation, all we've done is we've rewritten this equation in a different form. It doesn't change anything, because what was done to the left hand side was done to the right hand side, so it doesn't change the meaning of this equation. So this is essentially the same as the original equation. It's just been rewritten in the required form, where the coefficient of x squared is 1. Here you can imagine a 1 being there. Now computing the square just simply involves rewriting our equation in this form here. And in order to do that, we need to know what our b is and what our c is. By comparing the coefficient of x in the general form and the given equation, we can tell that b is 5, and we can also tell that c is 6. By comparing the constant terms, plus c plus 6 here, or you can imagine there's an x to the 0 here and an x to the 0 here, so we're just comparing the coefficients of x to the 0. So now that we know that b is 5 and c is 6, all we have to do is just rewrite our equation in this form, and that gives x plus b, in our case now b is 5 over 2 all squared equals, again, b over 2, so 5 over 2 all squared, minus c. In our case, c is 6. And in order to determine the valid values of x, all we have to do is just simplify this expression. Now, on the left hand side, we have x plus 5 over 2 all squared equals to, what's 5 over 2 all squared? Well, from indices you can tell that that's 5 squared divided by 2 squared minus 6, which gives x plus 5 over 2 squared is equal to 5 squared is 25, 2 squared is 4, minus 6. So now we have x plus 5 over 2 squared equals 25 over 4 minus, now instead of 6 you can rewrite 6 as 6 over 1, and just to make the subtraction of these fractions easier, let's rewrite these two fractions so that both have the same denominator, and this can be achieved simply by multiplying both the numerator and denominator of 6 over 1 by 4. So doing that gives 24 over 4. So we have, instead of 6 over 1, we have 24 over 4, and that gives x plus 5 over 2 all squared is equal to, now 25 minus 24 all over 4, which is 1 over 4. And we're almost done. This gives x plus 5 over 2 squared equals 1 over 4. Taking the square root of both sides gives plus or minus x plus 5 over 2 all squared, square root of that, divided by the square root of 1 over 4, plus or minus the square root of 1 over 4. Don't forget the plus or minus, very important. And as the conventional approach is to ignore one of the pluses or minuses. The conventional approach is to ignore the one on the left, just before the square root sign, which encloses the variable x. So doing that gives x plus 5 over 2 squared equals plus or minus 1 over 4. The square root of x plus 5 over 2 squared is x plus 5 over 2. In case you're wondering, remember that the square root of a squared is equal to a. The square root of a term squared is equal to the term that was squared. So in this case, the term that was squared is x plus 5 over 2, this bracketed term. So the square root of this term squared is equal to the term. That's what we have here. Plus or minus square root of 1 over 4 is 1 over 2. So let me just do that here. Square root of 1 over 4 is the same thing as the square root of 1 divided by the square root of 4, which is square root of 1 is 1 and the square root of 4 is 2. So we have 1 over 2. So we're now almost at the end. Subtracting minus 5 over 2 from both sides gives x is equal to plus or minus 1 over 2 minus 5 over 2. This can be rewritten as x. The right hand side here can be rearranged to give x equal to minus 5 over 2 plus or minus 1 over 2. And taking the plus case and the minus case separately from the plus or minus, we have x equals minus 5 over 2 plus 1 over 2, or x equals minus 5 over 2 minus 1 over 2. Simplifying gives minus 5 plus 1 over 2, or from here x is equal to minus 5 minus 1 over 2, which gives minus 5 plus 1 for minus 4 over 2, or x is equal to minus 6 over 2. Therefore x is equal to minus 2, or x is equal to minus 3. Just simplifying the expression, and that is your solution. And if we substitute x equals to minus 2 or x equals to minus 3 into the original equation, which was or is, or which was this, which was simplified to this, you'll find that, so let me just rewrite the original equation. 2x squared plus 10x plus 12 equals 0. When we simplified it to give the form, we got x squared plus 5x plus 6 equals 0. If you substitute the result we just got, x equals minus 2 or x equals minus 3 into this equation, you'll find that the left hand side will be equal to the right hand side, i.e. the equation will be satisfied. So the equation has been solved. The problem has been solved. The unknown values of x that satisfy the given equation, in this case this equation, are given by the method of completing the square. Now let's try a final example. So this example, the question says solve the equation 4x squared minus 24x plus 36 equals 0. We can use the quadratic formula to solve this, but we want to use the method of completing the square. So you have to remember that method of completing the square applies to an equation of this form where coefficient of x squared is 1, and all you have to do is rewrite it in this form, which is just simply a case of identifying the value of b and the value of c for your given equation, and then just replacing b with the value and c with its value. As simple as that. The first thing to do is to check that the coefficient of x squared is 1. It's not, it's actually 4 here. So what can we do? We divide the equation by the actual coefficient of x squared. We divide the equation through, in this case, by 4. Dividing through by 4 gives the following: 4 here, 1. So all of a sudden now, our equation's coefficient of x squared is 1. 4 in 24 is 6. 4 in 36 is 9. 0 divided by 4 is 0. So our equation now is x squared minus 6x plus 9 equals 0. We now have an equation in this form, and just to make it match this form exactly, let's rewrite it so that there are two plus signs. I mean, there's a plus sign before the bx term and a plus sign before the c term. So this can be achieved as follows: x squared, just introducing the plus before the minus sign, gives this, and just bracketing the term, because we know that plus minus 2 is the same thing as minus 2, because plus times minus is minus plus 9 equals 0. So now can easily determine that by comparing the coefficient of x in the general form to the current equation, we can tell that b is minus 6 by comparing the coefficient of x to the 0, or just by comparing the constant terms. In this case, c is clearly 9. So we have all we need to apply the method of completing the square. So to determine the solution values of x, simply write the equation in this form. We know what b is, we know what c is, so we just write x plus b over 2. It's minus 6 over 2. So let me just put this in a special bracket. Everything squared is equal to b over 2 squared minus 6 over 2, everything squared minus 9, because c is 9. And all we have to do is simplify this. So we have x minus 6 over 2 squared. Minus 6 over 2 is minus 3. So we have, let me just put this, we have, so almost done. So x plus minus 3, plus times minus is minus, so we have x minus 3 squared equals, what's minus 3 squared? Minus 3 times minus 3. That is 9, because minus 3 times minus 3 equal to 9, because the minus times minus is plus, and 3 times 3 is 9. So it's the same thing as plus 9, which is 9. Minus 3 squared is 9, minus 9. This gives 9 minus 9, which gives the x minus 3 squared is 0. Now just to find x, to make x the subject of this equation, take the square root of both sides. This gives plus or minus square root of x minus 3 squared equals plus or minus square root of 0. Drop in this, the plus or minus sign before this square root sign that includes the x, according to convention, gives the square root. This should be the expression, the simplified expression. So taking the square root of the left hand side gives x minus 3, because we know that the square root of any term squared is the term. And we still have plus or minus. The square root of 0 is 0. So it's, in order to finally make x the subject of this equation, just add 3 to both sides, or let's even drop the brackets first. All we have to do now is add 3 to both sides. So x minus 3, adding 3 to this side gives plus 3, plus or minus 0, adding 3 to this right hand side, the right also gives this. Simplifying gives x minus 3 plus minus 3 plus 3 is 0, so that kind of cancels out. Plus or minus 0 plus 3, rearranging this gives 3 plus or minus 0, or rather plus 3 plus or minus 0, which is 3 plus or minus 0, because plus 3 is the same thing as 3, you just ignore the sign. So this gives x is 3 plus 0, or x is equal to 3 minus 0, which means that x is 3, or x is 3. So from the plus case, from the plus or minus symbol, by considering the plus or minus, just considering the plus case, we got x equals 3. By considering the minus case, from the plus or minus symbol, we obtain that x is also equal to 3. So therefore, the solution to the equation x equals to 3 repeated. So it's a repeated solution. That's all. And if you actually replaced any of the original equation, which has been blurred now, with x equals to 3, you get that the left hand side is actually equal to the right hand side. So I want you to test the following. In the original equation, which is 4x squared minus 24x plus 36 equals 0, replace x with 3 and see if the left hand side and the right hand side match. Also try it with the rewritten form of this equation. We know we divided the equation 3 by 4 and got this form, and actually obtained the values of x from this equation. Replace x with 3 in this equation as well, and see if the left hand side and right hand side match. They should match, or they will match rather. Thank you.